All right, everyone, this is lesson 7.2.5, and this is when we're learning about a new way to kind of organize our proofs. We've been doing the bubbles, the flowcharts before, and we're going to learn about how to do flowchart proofs. But first of all, let's look at this pair of triangles right here. Apparently, these are not congruent, and so we're supposed to figure out why. Again, two requirements of congruency is that the corresponding sides are equal and the corresponding angles are equal. So it looks like these corresponding angles are equal, but when we look at the sides, 23s are corresponding, but the 26s are in different places. Those are not the same. So here, the corresponding sides are not equal. This pair of triangles, it looks like this could be a case of side angles side. We've got those two corresponding sides that are congruent. However, this one is 7 and this one is 6. Therefore, those two corresponding sides are not equal, and that's why these two triangles are not congruent. All right, let's create a flowchart for this proof. We are given that PM is a perpendicular bisector of AB. So here is PM, here is AB. And reminder, a perpendicular bisector tells us two things. The perpendicular part tells us we are creating 90-degree angles. So those two are 90-degree angles. And then the bisector piece, remember when you bisect something, it cuts it into two congruent parts. So when we cut AB in half, AM and BM are going to be congruent sides, congruent parts. So a perpendicular bisector is going to tell us two things that we just talked about, the right angles and the congruent sides. So we always want to start with our given information. PM is and I'm going to shorten this, perpendicular bisector, and that was given to us. And we're trying to prove that PA is congruent to PB. Now, we don't even have PA, so we're going to have to draw that in. There's line PA, here's line PB. This is what we're trying to prove. So whatever we're trying to end with is what we can fill that last bubble with. We are trying to somehow say that PA is congruent to PB. Now, I see two triangles here, and the alarm bells should be going off when we see two triangles and we're trying to say something about those triangles. We've seen a lot of proofs where we prove that the triangles are congruent to each other, and then by CP/CTC, we're allowed to say something about their parts. And that's probably where this proof is going. I'm probably going to want to prove that triangle 1 is congruent to triangle 2. So that then I could say that because of corresponding sides of congruent triangles are congruent, or CP/CTC, I could say that these two sides are the same. So that's kind of where I think my proof is headed. So let's go back to the perpendicular bisector. Again, the perpendicular part tells me I have two right angles, and because they're both 90 degrees, they're equal to each other. So I could say angle AMP is congruent to angle BMP. So angle AMP is congruent to angle BMP, and that is because of the definition of a perpendicular bisector. Just by definition, we know that these are equal because they're both right angles. And I'll talk about the two parts that are the same because of the bisector piece. AM and BM are congruent. So AM, I'm going to put the line over it, is congruent to BM. And again, that is simply because of the definition of a perpendicular bisector. All right, we have one more piece of information. And remember, I'm wanting to somehow prove that these triangles are congruent. So down here, I'm going to want to say triangle something is congruent to triangle something. And in order to say triangles are congruent, this is where one of our 5 congruency statements comes into play. So far, I've talked about an equal pair of angles and an equal pair of sides. So it could be SAS, it could be ASA, it could be AAS. So I'm either looking for another side or another angle that I could say is congruent. One thing that stands out to me, and it stands out to me because it's honestly my favorite property, is the reflexive property. I have a shared side between these 2 triangles right here, PM. So that is one more congruent pair of sides. So I'm going to say PM is congruent to PM. And that is because of the reflexive property. And now I have an angle and a side, and I know that spells out a bad word, and we know the bad word isn't allowed, but let's look at the order that they're in. We go from a side to an angle to another side. So this is a case of side, angle, side congruency, which means that I'm allowed to say that these triangles are congruent. So let's make sure we name these triangles in the right order. I'm going to call the first one PAM. So therefore, I have to call the second one PBM. And now, because I've said the triangles are congruent, this is where I get to use CPCTC. It's just like saying if the left side of my face is congruent to the right side of my face, I'm allowed to say that my left eyeball is congruent to my right eyeball. So because these 2 triangles are congruent, I'm allowed to say that PA is congruent to PB because they're parts of these congruent triangles. So our reason for being able to say that PA is congruent to PB is because of CPCTC. Corresponding parts of congruent triangles are congruent. So that's how we're used to seeing proofs done. We have another way of organizing our thoughts though, and this might be something that a lot of you guys like better than the flowcharts. I personally like this better than the flowcharts. We call this a T chart because it makes a T, and on our left side is where we put all our statements, or basically everything that's inside the bubbles. And on the right is where we put our reasons. And our reasons are all these things we've been putting under the bubbles, our justifications, if you will. I like this a lot better because I get confused with the bubbles of where to put the bubbles and what bubbles connect to what, and it's just this whole thing. So this might be a much more enjoyable proof experience for you. So they've already filled out some of the information, and if you notice, this is the exact same proof that we just did. So let's see if we can fill out this information just in a different form. So we have our given information, the fact that it's a perpendicular bisector. From there, we can say that the angles are congruent, and the reason for that is definition of perpendicular bisector. We were able to say one more thing about definition of perpendicular bisector, and that was that sides AM and BM were congruent because they got bisected. Okay, PM is congruent to PM. Let's look at why we said that. Oh yeah, that's because of the reflexive property. So instead of putting that a bubble and putting reflexive underneath, we just get to put this on the left and reflexive property on the right. Finally, we have the angles here and a side, but they're in the order of side, angle, side. So we are able to say that the triangles are congruent because of side, angle, side congruency. So I'm going to go ahead and say that triangle PAM is congruent to triangle PBM. So again, my statement, my reason. And now that I've said the entire triangles are congruent, I'm going to say that their 2 corresponding sides are congruent, and this is because of CPCTC. So this is the exact same proof, the exact same problem, the exact same line of reasoning. It's just formatted differently. And so if you have not been enjoying the bubbles, by all means start using the T-chart. And we're going to do a little bit more practice with T-chart proofs. Okay, so this is a problem that we've done before in the past. We are given two pieces of information. So when we look to make our T-chart, that is the first thing that we want to fill in. We always want to start with the givens. So AB is congruent to BC. That was given to us. And that's already marked on our picture. Next, we have that BM bisects AC. That's been given to us as well. And, okay, where's the M? Well, this we have to draw in. We have a line BM that bisects AC. We've talked about bisecting. This means it creates two congruent parts. It gets chopped in half. Now, this is not a perpendicular bisector. So we are not allowed to say that these are right angles. Okay, that was not given information to us. They might be, but we weren't told that, so we can't use it in our proof. All right, let's see if we can figure out where this proof is going to go. I'm trying to prove that angle BAC is congruent to angle BCA. So I'm trying to say that angle BAC over here is congruent to BCA. All right, this seems like another CP/CTC problem to me. If I can prove that triangle 1 is congruent to triangle 2, I could prove that their corresponding angles are congruent. So in looking at our congruency statements, here's the 5 of them. I have 2 pairs of congruent sides already. So I'm probably going to use one of the ones that have 2 sides, and we have 2 options. So I'm either looking for a pair of congruent angles or another pair of congruent sides. I see my favorite property again, the reflexive property. I'm going to go ahead and use that. We've got a shared side in the middle, BM. So this is going to be a case of side, side, side congruency. And I'm going to get rid of those angle markings to not confuse us. That's what we're trying to prove in the end, but we don't know that yet. So I got a little bit ahead of myself. We still need to say something about the bisection piece. Bisecting means that AM and CM are congruent, and that's because of definition of bisector. So I can say AM is congruent to CM, and that's definition of bisector. And now I can talk about my shared side. BM is congruent to itself because of the reflexive property. And now I have one set of shared sides up here, another set of shared sides, another set of shared sides. So this is side, side, side congruency, and that's a reason to say that my triangles are congruent. I'm going to call this triangle AMB is congruent to triangle CMB. Now my triangles are congruent, so I can say their corresponding parts are congruent. So I'm going to say angle A is congruent to angle C. And they used 3 letters here, so I'll keep that the same. Angle BAC is congruent to angle BCA. And that is because of CP/CTC. So me personally, I already found this proof much easier to do in the form of a T-chart, but again, that is up to you. All right, we're going to do one more problem. We're going to not attack this last problem. We have that ABCD is a rhombus. So when we are given that it's a rhombus, we're allowed to use all the facts we know about rhombuses, like the sides being congruent, or the opposite sides are parallel, so alternate interior angles are congruent, right? There's all sorts of things we could say about this. I personally am a big fan of side, side, side congruency we know that opposite sides are congruent, and we have a shared side here. So when I'm looking at these two triangles, triangle 1 and triangle 2 over here, I already know they're congruent by side, side, side congruency because it's a rhombus. So I think that's the direction I'm going to take my proof in. But let's look at what we're actually trying to prove. We are trying to prove that ABD, so ABD is congruent to, and this is in the wrong order. This should be CDB. So we're trying to prove that corresponding, no, I'm sorry, that's correct. Because with a rhombus, all the sides are congruent, not just opposite sides. I do not know my rhombus characteristics as well as I should. So those are the correct angles we're trying to prove are congruent, and those are corresponding. So let's go ahead and make our proof. So we always want to start with our given information. That's the easiest place to start. And we're given that's a rhombus. Whoops, given goes on the other side. A, B, C, D is a rhombus. And anything we take from that statement, our reasoning is just going to be definition of a rhombus. So one of the first things we said is that AB is congruent to CD. And that is because of definition of a rhombus. And AD is congruent to BC. I'm talking about the opposite sides here, even though they are all congruent to each other. So I could just put all these congruent to each other in one line if I wanted to. And then finally, favorite property, I've got my shared side, BD. So BD is congruent to BD, and that is because of reflexive property. Now I have side, side, side congruence, side, side, side. So I can say my triangles are congruent. So ABD is congruent to triangle CBD. Because the triangles are congruent, oh, and I'm sorry, the reason for this is side, side, side. Because the entire triangles are congruent, I can say their little parts are congruent, so I can now say what I was trying to prove in the first place is that angle ABD is congruent to angle CBD. And this is because of CPCTC. So that's what we have for T-chart proofs.